A quote from Thomas Kochen, former NASA science director, on the launch of JWST, James Webb Space Telescope. James Webb marks the beginning of a new era in astronomy. Webb will expand and test our cosmology and our understanding of planets and the origin of life. What began hopefully turned into a debacle. James Webb has shocked scientists. Will the crisis now get worse, or will a new discovery of the James Webb Telescope end the debate in physics? The discussions about old theories and who is right or wrong could indeed be coming to a temporary end. But what exactly does this mean? Have scientists really unraveled the mysteries surrounding James Webb's impossible discoveries, or are we just being stalled with flimsy explanations? James Webb was supposed to bring solutions, but instead, the $11 billion project plunged cosmology into a major crisis. All parts of natural science associated with space are currently experiencing a shakeup of the kind we last saw in the Middle Ages with the shift to the heliocentric view of the world. Now, we may have to recognize that the foundations of our modern physics are also flawed and that we have not come close to understanding what our cosmos really is. But how is this possible? Today's astrophysics, or in other words, the science of the physical quantities and relationships in the cosmos, is based on the basic rules of physics, which essentially go back to researchers of antiquity, the Middle Ages, and in particular, to Sir Isaac Newton. The first observations of mechanics and dynamics were made in antiquity. Quantities and forces were described for the first time. Later, Newton discovered gravity, which is so important for astrophysics. We built our scientific observation of the universe on these foundations. We transferred the quantities and forces that were valid and observable on Earth to the universe, and this produced some consistent results. But then the space we can see got bigger and bigger, and at a certain point, our known quantities no longer fit to describe what we see. This crisis began with the problem that different methods of measuring the age and expansion rate of the universe led to contradictory results. Local measurements based on astronomical objects within the universe gave different values than measurements of the early universe based on the cosmic microwave background radiation. We know this dissonance as the Hubble tension, while the Hubble constant indicates the expansion rate of the universe. In the summer of 2022, Webb discovered so many old and highly developed galaxies in space that doubts arose as to how the age of the universe was determined. Our cosmos can hardly be 13.8 billion years old if, thanks to Webb, we see galaxies that were already well developed 200 to 100 million years after the Big Bang. According to the calculations of our physics, galaxies need billions of years to grow. In the case of the galaxies discovered by Webb, this would even mean that the time of their formation was before the Big Bang. Our old cosmology, according to which the universe began with a Big Bang 13.8 billion years ago, has been expanding ever since and has undergone a slow process of evolution of matter, cannot be correct. We are at a crossroads. Either we are making a mistake if we think that our earthly physics can be applied to the entire universe, or we have so far only deciphered a small part of the physics that really exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." According to this maxim, all the physics that exists in the cosmos should also be found on Earth. But perhaps we have overlooked forces and dimensions on our planet that we are now noticing in the cosmos. Webb breaks all records. It's fantastic. This telescope can pick up extremely weak light signals. Webb's 18 honeycomb-shaped mirrors effortlessly detect light that has traveled through space and time for more than 13 billion years. A special exposure method makes these faint traces of light visible for the first time. Thanks to this new revolutionary technology, we saw the light from the most distant galaxies that formed shortly after the Big Bang for the first time in the summer of 2022. These galaxies were a sensation and at the same time a bitter disappointment. Instead of baby galaxies, Webb shows perfectly developed galaxies that appear to be several billion years old. But with an age of 13.5 or 13.6 billion years, this can never be the case. These days, scientists sometimes say that the objects and the images are impossible or not real. But well, can only show us the truth. Science must now admit that it has probably been on the wrong track for more than a century. That's roughly how old our standard cosmological model is. What we see here is real. Webb works perfectly. It's just that large parts of our science are still unable to come to terms with the new truths. Some of the old traditionalists who don't want to look the new truths in the face vehemently oppose the end of the Big Bang or the idea of expansion. In the Middle Ages, it also took many years before the Church was finally willing to admit that the Earth was not the center of the universe, even though there was suddenly masses of evidence from astronomers all over Europe. So, not much seems to have changed. And although we consider ourselves much more modern today, we have a similar scenario. Researchers who proclaim something new may no longer end up in prison like Galileo Galilei, but the quarrels between researchers and the hostility towards new things are still there. Imagine you have spent a lifetime researching and firmly believing in something, and then suddenly you see images or another side of reality that tell a different story. Perhaps your mind would also rebel against this at first, and it would take a while before you could accept the new truth. As everywhere, there are some who are quicker to adapt and others who take longer. Many open-minded and young scientists are enthusiastic about Webb's discoveries. Rohan Naidu, the discoverer of the Glass C11 galaxy, and Stefan Lin, who discovered Mace's galaxy, belong to this open-minded generation of researchers. They look at Webb's images with an open mind and have been studying them since the first moment of publication. Both astronomers emphasize several times in interviews that we simply cannot know what will happen in astrophysics. At this moment, we have to wait for further measurement results, studies, and of course, Webb's latest images. Was it Hubble's fault? Let's take a look at the debacle. One of the great debates in modern cosmology concerns the Hubble constant, the rate at which the universe is supposedly expanding. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies were moving away from us. From this he concluded that the universe is expanding. The idea was later expanded upon, and the Belgian astronomer Georges Lemaitre postulated that this expansion originated from a single point, the Big Bang. Today, we already know from alternative methods that the movement of galaxies can also be explained differently, and these approaches also provide a coherent picture in their entirety. However, they were ignored for a long time because the old theories were considered more probable. But the more we see of the universe, the more discrepancies emerge. This didn't just start with Webb. Even 20 years ago, there were regions in space where the expansion was behaving differently. It was as if these regions were sometimes faster and sometimes slower, or perhaps denser or emptier. This led to speculation that there may have been several starting points, or that our universe is even permanently fed by several sources which do not necessarily all have to have had a beginning at the same time or at all. Alternative ideas about the shape, nature, and age of the universe emerged once again, but researchers continued to cling to the old theories of the Big Bang and expansion. This was possibly a mistake. We have already briefly learned about the Hubble tension. In short, it shows clear differences in distance measurements in the universe depending on which fixed points we use as measurement constants. Now, scientists hope that the Webb telescope, as its mission progresses, will be able to resolve this tension by making precise measurements of the distances and redshifts of galaxies. This could correct errors in previous measurement methods and pave the way to a new, advanced physics. In the end, all researchers have done their best in finding explanations and theories, and they have advanced humanity's knowledge of the cosmos. We should therefore not discuss guilt, but rather look ahead and rejoice in every new discovery, even if it seems unfamiliar or even shocking at first. New theories and alternative explanations are on the rise. We are probably at the exciting beginning of a new science. New investigations of these oldest points of light could show us whether they are accretion disks or jets of supermassive black holes, and what is in their vicinity. We would then have to revisit our cosmology and find out whether black holes played a much more important role in the discovery of the universe than previously thought. One theory that points to this comes from the British scientist Roger Penrose, who believes that the universe is constantly recreating itself in cycles and that black holes could somehow survive such transitions as gigantic stores of information. Penrose published this theory long before Webb was launched, but although the Briton is a renowned researcher, his work was not accepted. That is now changing. Webb's mission has only just begun. We already have a second deep image. When we have the discovery of a very old structure that is so large that it also does not fit into the young universe, this evidence is growing. We still have to wait and see what new images from Webb will reveal. The telescope is not only exploring the young cosmos but is also working around the clock to complete our knowledge of exoplanets, discover new worlds, shine a new light on our own solar system, and image the most massive and beautiful structures in the cosmos in unprecedented detail. Each of these observations in the universe is ultimately a piece of the puzzle that completes the overall picture. Even measurement data on exoplanets can broaden our focus on the overall picture and provide important clues about unknown forces, anomalies, or previously unknown phenomena. There must be something like a basic matrix, and our scientists are looking for its sizes, numbers, and structures. Thanks to Webb, a revolution has now begun that is currently still causing unrest and heated discussions. But we can rightly hope that the crisis will bring us a little closer to the truth. Click the subscribe button now, many more exciting videos to follow.